Today we're going to look at the resolution of forces. The last 2 days we've been taking vectors and adding them together, creating a resultant, the result of two smaller vectors, and basically the diagonal of the parallelogram, right? Our objective today is to sort of work backwards. We want to resolve, figure out what two initial forces produced this resultant. And we're going to do that basically in two ways. Okay, we're going to look at right angle triangles and specifically the horizontal and vertical components that produce a diagonal. Okay? The reason we like this is we can use Pythagoras and SOHCAHTOA to solve the parts and pieces of this right angle triangle. And a little bit easier to do than a non-right triangle. Okay, so we'll take a look at the first example. I'll show you how this is going to work. Okay, we've got a football. It's being punted with a force of 150 newtons at an angle of 40 to the horizontal. Okay, so there's my horizontal, there's my football. This is 40 degrees. Football is traveling at 150 newtons. Okay. What is the magnitude of the force that propels the ball forward? So what's causing this ball to go towards the goalposts, right? That'll be down here. We'll call that our horizontal force. Okay, this is a right triangle. Well, if I want to solve that, thinking about right triangles, this is my adjacent. This is my hypotenuse. SOHCAHTOA tells me if I take the cos of 40, that will be my h, the horizontal force, over my hypotenuse, 150. From way back when, let's solve this. We can cross multiply. 1 times h is h. 150 times the cos of 40. We can put that into our calculators, and we'll end up with 114.9 newtons. Okay. For part B, I want to find the vertical force, the force that raises the ball. That would be up here, right? Based on our angle, that's our opposite. So I can use the sine of 40 this time. My opposite is the vertical force. Hypotenuse is still 150 newtons. Same problem, just using a sine this time, so we can cross multiply again. 150 sine 40 into our calculator, and we get 96.42 newtons. So comparing these two forces, there's more force carrying the ball forwards, that is our horizontal force, than there is lifting the ball, 46 only. Which kind of makes sense in terms of football. You want the ball to travel further down the field than straight up in the air, right? Okay. Take a look at the second one. Give it a try if you can. See if you can figure it out. We've got a train traveling 200 kilometers an hour in a direction of north 55 east. Okay, so we know this is 55, and our train is going along here. Okay, it's traveling diagonally, but it's also covering two different directions at the same time, right? It's going north and east. And the question wants us to determine the magnitude of the perpendicular components. It wants us to know this component, which would be our northerly component, and this component down here, the easterly component. How fast is it going north? How fast is it going east? To do this, I kind of need to know the angle inside the triangle, right? We know this is 90, so 90 minus 55 will give us 35 degrees inside the triangle. Now, if we want to do let's do the northerly one first, just somewhere to start. This would be my opposite and my hypotenuse. O and H, sine, so the sine of 35 equals n for north over 200. Cross multiply, so n is 200 sine 35, and that comes out to 114.72 kilometers per hour. So every hour that it travels, even though it's going 200 kilometers an hour, it's actually covering 114.72 kilometers in a northerly direction. Okay, if I want to do the same thing, but this one I want to find out the easterly direction. So that's down here. That's my adjacent. Still have my hypotenuse. Becomes a cos question, but it's the same idea, right? Cos E over 200, E for east. I cross multiply that, same process. And you'll kind of notice there's a pattern here. We use the same process multiple times. 200 cos 35 comes out to 163.83 kilometers per hour. So our train's going 200 kilometers an hour, and it's covering northerly direction, 114. and easterly direction 163, which should make sense. Based on our angle, we're more towards the east than we are towards the north, okay, which gives us a bigger easterly value than a northerly value. Okay. I've got one more example in the back. Give it a try, see if you can figure it out. It's basically the same ideas. So here's your last chance to practice one of these before we move to the homework. Okay, we're pushing a lawnmower. Gardener exerts a force of 250 along the handle. The handle is inclined at an angle of 60 degrees towards the ground. Okay, so this is my handle. There's a little clip art there to show you. But 60 to the ground. And you're pushing at 250 newtons along that, right? The lawnmower is going forward based on the angle we're pushing at. Find the force that moves the mower forward. So if I turn to a right triangle, my forward force would be the horizontal one, right? Okay, based on that, we're doing a cos question. We've got an adjacent, that's the horizontal force, and we got our hypotenuse, that's our 250. We're going to cross multiply 250 times the cos of 60. That's going to come out to 125 newtons. Okay, half of our energy is pushing this mower forward, right? Half of the 250. Okay, what's the magnitude that tends to push the mower into the ground? That would be your vertical force, right? Keeps the thing on the ground. Putting sine this time. So sine 60 equals h over 250. Cross multiply 250 sine 60. And 250 sine 60 comes out to 216.5 newtons. And a lot of force being used just to keep the lawnmower on the ground. To pushing it into the ground. Is that an effective tool? I don't know, right? Okay, part C. How would the person pushing the mower be affected if the angle was increased? Yeah, steeper angle. So instead of 60, maybe it's 70 or 80 or 90. 90 may be a little silly, but we could do something like that. What do you think? All right, well, the higher the angle gets, the more force that's being pushed downwards, right? If you don't believe that, try it. Try to figure out the vertical force. Actually, starting this last one here, it shouldn't have been H. That should have been a V there. Okay. And the last one, instead of sine 60, try sine 70. See what happens. If I were to punch in sine 70 equals V 70 over 250, and then solve that one, 250 times the sine 70, and give that a try with my calculator, I bet you the number I get will be bigger than it used to be. And just try it there. 250 sine 70 comes up to 234 this time. Right? The higher the angle gets, the more energy is being wasted holding that mower down. So if I was putting this into words, okay, the higher the angle, the more energy being wasted, not keeping, well, pushing the mower into the ground. Right? If we lower the angle, right, we're being more effective. Right? We're pushing that mower forward easier. The higher the angle, the more work we're doing keeping the mower down. Okay, and that's how we can resolve a resultant into these two perpendicular parts. Okay, so a couple questions you guys can try for homework tonight. And then we'll move on to some more ideas about how we can manipulate vectors.